Alright, hello everyone. This video is gonna be kind of special because this is going to be my first video on calculus. I don't exactly have the same energy as before. Back when I was teaching, showing how to solve lessons back in grade 10, grade 11. It's been apologize that the previous videos have been without voice. I just needed a lot of time to prepare for my exams, and I couldn't really invest too much time on this. But yeah, I'll try. For this one, we have our quarter exam next week, and I just want to share to you what I've learned so far on calculus for the past weeks, since the beginning of our third quarter, our first semester in grade 11 STEM. So we'll start with limits. I'll be basing all the lectures here with my teacher's presentations. So first, we have this kind of graph wherein, let's see, here is, no, let's put it here. A minus, I believe this is delta. Let's just say delta. And then we have A here. This one is A plus delta. And then at this side, we have L minus, I believe this is E, not sure. Better to consult the internet about this, but I'm just copying what the graph looks like. Don't expect this video to teach, to show what you're looking for in a calculus video. This is just to record my progress on calculus review. The past week and this week, it's pretty difficult, but yeah, I'll keep driving on. And then we have a curve here. Okay. By the way, this term, it's just an adjective. I'm sorry. It's not taken literally. It's figurative. I think you get the idea, hopefully. So for the definition of a limit, lim f of x, such that x approaches a is equal to L. For every e that is greater than 0, there is a number wherein delta is greater than 0, such that 0 is less than the absolute value of x minus a, which is less than delta. Then the absolute value of f of x minus L is less than e. Even for me, this kind of doesn't make sense. We'll see if it makes sense later. So the limit of a function exists if and only if the one-sided limits of the function are equal. So we acknowledge that this is what it is. And for its one-sided limits, the left and the right-hand limit, we should know that the limit exists if they're equal to each other. So lim f of x such that x approaches a from the left side. This is the left-hand limit. You know it because the symbol here is negative. It should be equal to lim f of x such that x approaches a from the right side. So L, that means, I believe that means limit exists. Okay, so we'll be highlighting this. It's gonna be important information. All right. So let's move to some laws that are relevant to this topic. We have the direct substitution law. Here, lim of f of x such that x approaches a is equal to f of a. We have our next law, which is the constant law. Here, we have lim c such that x approaches a. That's going to be equal to c. That's it. Let's have some examples under constant law. So, for example, for number 1, we have lim 3 such that x approaches 0. That's going to be 3. Second example, the limit of negative 10 such that x approaches negative 1, it's still going to be negative 10. Alright, our next law is the constant multiple law. Here, lim c of f of x such that x approaches a is equal to c lim f of x such that x approaches a. So what you have to notice here is how c is repositioned in the expression. Let's see how that kind of system works in 2 examples. So example 1, limit 5x such that x approaches 2. That is going to be, we know that c is equal to 5. So the other form, we write it as 5 lim x such that x approaches 2. And that could further equal to 10, I suppose. So for number 2, lim of negative 12x such that x approaches negative 1, that's going to be equal to negative 12 lim x such that x approaches negative 1, which could be equal to 12. Apparently, I think here, how you're able to get 10, you just multiply 5 and 2, these two numbers. That also goes the same with the second example. Multiply negative 12 and negative 1 and you get positive 12. I'm not sure how if we're supposed to disregard the lim sign. But yeah, based on our observations, even I don't really know. I think that's how it works. That's the beauty of being able to critically observe what's going on, even if you're not sure about how things actually work, especially in the context of problem solving. So sum law and difference law, these are 2 more that we have. For sum law, literally from the word sum, we use addition. Addition of what? Addition of the limit of f of x plus g of x. So you find the sum of f of x and g of x. such that x approaches a. This is basically a reverse distributive property. Oh, no. This is you apply distributive property. So that's going to be equal to lim f of x such that x approaches a plus lim g of x such that x approaches a. For the difference law, it's pretty much the opposite. Everything is still the same, but the difference is the subtraction sign. There you go. So let's have one example for sum law. For the sum law, let's say lim 3x plus 1 such that x approaches 0. We can distribute this lim 3x such that x approaches 0 plus lim times 1 such that x approaches 0 you can apply the C thing, the constant multiple law. Lim C is equal to C lim, so lim C becomes C lim. Everything else is copied. And what eventually happens is, so 0 times 3 is 0. And here it's just 1 for this one. Yeah, I think you apply the direct substitution law. Wait, no. Maybe not. The constant law, rather. Such that 1 is your C, and it's going to be the answer anyways. It's still going to be 1. You disregard the x approaches 0. We'll find out later when you know that it's constant law that you'll be using, or the direct substitution law. Let's move on to the next law, which is product law. So limit of, okay, so we're still going to use distributive property for this one. That's one good thing to know, so that we don't really get to spend more time memorizing these laws if we're mandated to. We could just replace the signs. They're the same. So multiplication law, distributive property. So for example, limit of x times the quantity x plus 2 such that x approaches 4. Limit of x times the limit of x plus 2 such that x approaches 4. And then if there is no x, if there is no value for x here at this part, and we know that x approaches 4, I believe the best thing to do is to substitute them. So 4 times 4 plus 2. So that makes 6 times 4, or 4 times 6. That is 24. Let's move to quotient law. So the concept is still the same. You apply distributive property, but this time, of course, it's quotient. It's gonna look like a fraction. something like this. And what's going to happen is that it will look like something, so it will look something like this. So of course we'll be assuming that the denominator, this part, is not equal to 0, because we all know that every number that is divided by 0 is going to be undefined. We don't want that. So this is the quotient law. Let's find an example. Let's say limit of 7 over 2x plus 3 such that x approaches 2. And so limit of 7 such that x approaches 2 over limit of 2x plus 3 such that x approaches 2. That's going to be well, I think we use the constant multiple law for the numerator. Oh, sorry, the constant law only, not constant multiple. So lim c such that x approaches a, still going to be c. So this is 7. And then below, the denominator, we apply direct substitution, I suppose, since we don't know what x is. So yeah. I guess that's going to be 2 times 2, that's 4, then 4 plus 3 is 7. So 7 over 7, we get 1. That's our final answer. Okay, it starts to make sense. For direct substitution law, we apply this law if our x does not have any value or any specified value at all. We use constant law if there's already a constant beside at the right side of lim. I think that's how things work now. Okay, let's take on more example. Let's move on to power law. I believe this is the strongest, the most powerful of all the other laws, or at least that's what my teacher told me. So lim f of x such that it approaches a, it's going to be raised to n. That is equal to lim of f of x raised to n such that x approaches a. Alright, lim f of x, lim f of x. The question is, what changed? I don't see much. Oh, wait. I think it's just a parenthesis. Let's take a few seconds to digest what has been showcased. So let's use one example. Let's try to apply the formula. Lim x raised to 3 such that x approaches 1. That could be lim x such that x approaches 1. We make a big parenthesis, and of course the traditional thing, if x is not given, then we use whatever number is described as a in x approaches a. Well, apparently here it's 1, so lim 1, that's going to be just 1, and then 1 raised to 3, it's still going to be 1. Let's try out the second example. limit 2x raised to 2 such that x approaches negative 1. So lim 2x, x approaches negative 1, then raised to 2. And then lim times 2 times negative 1, that's going to be negative 2, I suppose. Alright, I need a few seconds. Let me just double check. My answer is kind of different from what the presentation is trying to show. Alright, so currently it's still raised to 2. So if it's negative 2 because of 2 times negative 1, wait, sorry. This becomes 2 and then negative 1 and then raised to 2. That becomes positive 1 and hence we get 2. Oh wow. My initial answer was supposed to be 4, but this showed a different kind of method, which is supposed to be generic in nature. It's supposed to be like how you actually solve it. Alright, so next question. Oh yeah, I think I can see the reason why now. We don't multiply 2 and negative 1 first because of the PEMDAS rule. You have to the exponent comes first, so use exponent first and then you multiply. So for the root law, we have lim square root of f of x such that x approaches a. That's going to be basically the entire square root will cover just everything, just like this. We assume that n is a positive integer. Let's try an example. Limit of limit of the square root of 18 over x minus 1. So with this, we have the square root of limit 18 over x minus 1 such that x approaches positive 3. By default, any square root without any given whatever the n is here, it's always going to be automatically 2. Just like how for x there will always be an invisible 1 since the number is still the same. So 18 over 3 minus 1, I guess, and for some reason we don't use the quotient law. Well, we actually do technically, but then we don't really feel it here. So 18 over 2, that's going to be 9, and that's going to be 3. So the answer is 3. let's move to, all right, we're done with all the laws. So far we have direct substitution, constant multiple, sum, difference, product, quotient, power, and root. These are kind of not so familiar to me, but I'll eventually get used to it. I hope you will also get used to it. So let's answer several practice questions. It says, evaluate the limits. So the limit of limit of 5x raised to 2 minus 3x plus 4 limit, I guess this is direct substitution. We use direct sub since we don't know what x is, and given that we have x approaches 1 as our x approaches a, we substitute a with x with a. Let's double check. Definitely not constant law or constant multiple law. Yeah, I bet it's direct substitution. So what we do is 5 times 1 raised to 2 minus 3 times 1 plus 4. Okay, 5 times 1 minus 3 plus 4. 1. Okay, 5 plus 1 is 6, I guess. I don't think we have to put the limit anymore or write it down. I'm not sure, but I bet that's the answer. Okay, second question. Limit of x raised to 2 plus 6 over x such that x approaches 2. Limit of, well, I think we apply the same kind of thing, direct substitution. Lim of 10 over 2, it's basically going to be 5. Alright, buy me a few questions. Kindly skip this part if, it's going to take kind of long. I'll be back for a while. Alright, let's move to number 3. Limit of limit of the square root of y raised to 2 minus 9 over 2y raised to 2 plus 7y plus 3. such that y approaches -3. Alright, limit of, I think we also substitute again. -3 times -3 is +9, so that's this, and so 9 minus 9, 2 times -3, so that's 9, plus 7 times -3, that's minus 21, then plus 3. Limit of 0 over, I think this is already going to be 1, whatever the denominator could be. So 18, oh, this is also 0. So I think this is 0. Let's double check using Photomath. Okay, apparently Photomath has a different answer. Let's check if alright, it's square root of 30 over 5. Okay. Okay. We apply conjugate. That's what I kind of forgot to do. Anyways, by the way, for these solutions, there should always be lim and then the x approaches a. Otherwise, the solution could be wrong, even if you get the answer correctly. So, tread carefully. We know that we have to apply conjugate or use the conjugate. I suppose under the conditions you're in, you need to rationalize the denominator. Not sure why we can't just substitute immediately, but definitely if your answer is 0 over 0, it's still going to be indeterminate, as you can see here. And so you have to try another way. So we'll just factor the denominator. So also the numerator, we factor both. Okay. Wait, we don't have to apply the conjugate though, because simply by looking, you can cancel these two. So yeah, I think that's one thing you could note. You don't have to apply conjugate if this is the situation. You could just cancel. Let's see what happens next. Okay, we can substitute values. Direct substitution law. So that's going to be -6 over -5, I think. Wow, this is... Oh, okay. We do have to rationalize the denominator. This is where we have to rationalize. By the way, these could be positive already. So to rationalize, we multiply both sides with the square root of 5. We don't want any radical signs on the denominator. It's ugly and I don't think it's allowed for the final answer. So square root of 30 over 5. I bet this is the answer already. Yeah. Let's go with number 4. Let's move it here. So the limit of x approaching 3 such that x plus 1 minus 2 over x minus 3. Okay. Not sure what to do here. Alright, this is where we apply conjugate. Yeah. So we have x plus 1, then square root of x plus 1, then plus 2. Conjugate, we just copy whatever is inside that particular radical sign, and whatever that integer that's beside it could be, make it either, if it's negative, then make it plus here. If this is positive, then make this negative. So yeah, let's multiply them. So x plus 1, and then these two cancel. These two is going to be negative 4, and then x minus 3 times x plus 1, then plus 2, I guess. Okay, one thing that you would want to know is that try not to simplify the denominator or try to expand it in any way before you can see that, because there's a tendency that you can still cancel something. So in this case, let's just simplify the numerator. That's going to be x minus 3. And apparently, below, we have one identical two terms surrounded by a parenthesis. That's going to be these two. So cancel them. We get this. And then I guess this is where we apply the direct substitution, our favorite law, the first of the first that we discussed. It's going to be this is going to be square root of 4, that's 2, then plus 2, we get 1 over 4, and this is our final answer, I think. Yeah, there you go. Now we're getting it. Okay, we have 2 more examples before we end this video. The next videos will focus on the other presentations that were that succeeded this topic. Eventually, we'll be tackling differentiation and derivatives, something that I'm not really confident about currently. So here, I bet we can expand the numerator if there's something that we could cancel. There you go. Could cancel x minus 1, and then we have x plus 1 left. Because of that, we can apply our favorite law, that is the direct substitution law. So we have 1 plus 1, that is 2. I think this is the answer. Let's check using Photomat. Yeah, the answer is 2. Right, let's move on with number 2. Last question. Limit of the square root of x, then minus 1, and then x over x minus 1, such that x approaches 1. So I believe we used to conjugate. We'll be using conjugate in this question because we have a square root, something that's similar to this one. If you can see, they're identical. Always know that we'll be applying the conjugate. Conjugate, conjugate, conjugate. Keep on copying the limit, and then the x approaches a. Multiply numerator and denominator with square root of x, then plus 1. So limit could be the square root of x times the square root of x is basically going to be x raised to 2. The square root of x raised to 2. That's going to be x basically. So these two cancel. FOIL method, and then that's minus 1 for this part. Below, we have x minus 1 times quantity square root of x plus 1. So we have something that we could cancel, these two. And so lim 1 over square root of x plus 1, such that x approaches 1. That's basically going to be, it's going to be 1. Square root of 1 is 1, so 1 over 2. I think this is the answer. Let's check the solutions before. Yeah, 1 over 2. It says here, apply conjugate technique. Okay, thank you for watching this video. Hope it helps. Take this from someone who's just a beginner in this topic. This is limits, definition, and rules.